this diagram and we want to know what fraction of the largest square is shaded. Notice we've got this octagon around the outside. Now this is going to involve finding the area of the shaded region and divided by the area of the whole region. So we're going to need to do some calculations on area. It's not, however, going to matter what the side lengths are because we're only interested in the fraction, the amount that's shaded. As you enlarge it or make it smaller, the fraction will stay the same. So you can imagine I'm going to make it so that the side length is something of my choice. Now, when I did the question, I went with 1, but it's actually a good idea to go with 2 for reasons that I'll show you in a minute. What this means is that this length is also 2, and I end up with an isosceles triangle with hypotenuse 2. So this is x and this is x, which means x squared plus x squared, or 2x squared, is going to equal 2 squared, or 4. Actually, let me write that a little bit more slowly. So x squared plus x squared is 2 squared, which means 2x squared is 4. So x squared is 2, and x is root 2. The reason 2 works really well, because if you do the same thing with 1, if you had 1 here instead, then you get 1 over root 2, and you just get these fractional surds. It's just not quite as nice to deal with. So I'm going to stick with this, and we're going to stick with, root 2. Okay, so that means this is root 2, this is root 2, and the same down here. Well, it's absolutely fine to start with 1, for example, or some other number, or even x, and just at some point you make it something that's going to work more nicely. There's lots of problems on math challenges where this is the case. You end up thinking, oh, actually, if I make it a multiple of 3, then I avoid having to divide by 3, and so on. Okay, so let's look at the whole square. Okay, the area is going to be 2 plus 2 root 2, because that is the height, times 2 plus 2 root 2. So I'm squaring it. I'm going to write it as a double bracket. Okay, so rather than having fractions, I end up with multiples of surds, but it's absolutely fine. So I'm going to get 4 plus 4 root 2 plus 4 root 2, so 8 root 2, plus 2 root 2 times 2 root 2, which is 8. Because I do 2 times 2 to give me 4, I do root 2 times root 2 to give me 2, and then 4 times 2 is 8. So overall, 12 plus 8 root 2. Okay, now the shaded part. Shaded square. Okay. Right, remember, this is actually very important. I've not talked about it. It's the midpoints. The shaded square connects the midpoints of 4 sides. So that means that this length, because the whole amount was root 2, then this is going to be root 2 over 2. But then so is this. So if I add those two together, then the bit that I lose from 2 plus 2 root 2 is actually a whole amount of root 2. What I'm saying is the shaded square area is simply going to be 2 plus root 2 all squared. Because I've got my 2 plus 2 root 2, I'm minusing root 2 over 2, I'm minusing another root 2 over 2. That's going to give me 2 plus root 2. Okay, multiply these out. So again, 4, 2 root 2, another 2 root 2, so 4 plus 4 root 2 plus 2, which gives 6 plus 4 root 2. Okay, and we're nearly there. What fraction do we have? Well, I've got my 6 plus 4 root 2, and I'm dividing by 12 plus 8 root 2. In fact, I can see that I've got a multiple, the bottom is a multiple of the top. I've got 6 plus 4 root 2 over 2 lots of 6 plus 4 root 2. This has worked out really nicely. These two cancel, simply leaving me an answer of a half, which is not what you'd expect at the start of this question, that this is a half of the area, but that must be the answer. We've proven it numerically. Well done.